Hello guys, I hope you're doing well. Welcome to my YouTube channel, which is Data Science Gurus. Today we will do the implementation for text classification between the spam messages or spam emails and non-spam emails. So first of all, in our previous lecture, we have discussed in detail that how to install Anaconda and how you can install different libraries if you are having package or library issues, and so you can watch that video. Okay, so today we are going to discuss in detail about the code, about implementation, libraries, data exploratory analysis, and everything in detail. So first of all, you have to go to the Anaconda, and today, like in this folder, I have my data set, which is in an Excel sheet, which has the two columns. The first column is these are the actually labels. This ham actually denotes that this is a not a ham or not spam, is basically denote the label of that specific SMS or email. Okay, and this has the label spam. So we have different records in this Excel sheet, and we will work on this data set to design a machine learning model so that we can simply give it after the training and testing, we can simply give it a text message, and it will help us to classify that whether this message is a spam message or is a non-spam message. Okay, so this is our data set. It has two columns, the first one and the second one, and we will do the exploratory analysis and all the other steps that are compulsory to design a machine learning model. So before going to the topic, first of all, you should know that you should have Anaconda installed in your system, and after that you should go to the Anaconda prompt. Here I am in this is my in D drive, so you have to copy the address here, and you have to uh, type the cd command and space the address of that specific folder. So for example, in this uh, specific scenario, we have to copy this, and we have to paste it here by after the cd space this command, and after that it will be in that specific folder. After that you have to type Jupyter space notebook. Okay, and when you will press enter, and it will open Jupyter Notebook for you, and you will be having this kind of interface. Okay, and here we this is our data set, and this is our spam SMS spam detection Jupyter Notebook, in which we will be having different codes. So here today, this is a Jupyter Notebook is an IDE for Python. You can also use different ones as well, and you can also implement it in other ones if you're comfortable in PyCharm. You can have the PyCharm. You can open PyCharm in your from your Anaconda. If you're comfortable with Spider, you can simply go to the search bar and you can type Spider here. So you will click on it and you can run, but you have to like there's a difference, there's a bit difference. So that's why we are using a Jupyter Notebook. Okay, so so after opening the Jupyter Notebook, you will be having these two files, as these two files are here. This is a data set, and this is a Jupyter Notebook. Okay, so it will be open in your most probably in your Microsoft Edge. So you have to click here, and it will be open in the um, next window. And the first step you have to follow is you can simply double click on it, or you have to, if you want to change the name of your Jupyter Notebook, you simply click here and you can simply change it, and uh, then you can click on rename, and then you can simply rename it. Okay, so first of all, you have to import the libraries. Okay, so NumPy, Pandas, Matplotlib, you can learn about them. Then what are these libraries used for? These are mostly used for the for loading the different JSON files, Excel sheets, and other data sets. Okay, so NumPy to load the arrays. Pandas is used to for the data manipulation. Matplot is used for the plots, and cburn is also used for data visualization and warnings. If you have any warning messages, so you can also, if it depends upon your data set. Okay, so here you have to click here, and you have to click on the run button, and after it, uh, if it don't have any error, then it will show one or two or three here. Okay, and when you will be running for the first time, you will not be having any number here. So for example, if I run it here, so it will show us this as I've run this before, so that's why it is showing us that. For example, if I'm gonna refresh this page, and we can start this from starting, so that um, we can have our um, so that how we can see that how it is actually working. So here you have to go to the click here and type run. Okay, and here it's done because it's working. After that, you have to, as we have imported the pandas library as PD, so we have to upload the data set, because the data set is in CSV. I mean to say it's an Excel sheet. So we are using a CSV file, pd.read CSV file, and encoding is latent dash one. Okay, and our data set is loaded in the df. Okay, the df is basically called as a data frame. Okay, so here you can load the data set. After that, if you want to display the first 5 or 10 records, then you have to type a df.head. Okay, for example, if I want to, for like, first we can run this, we have to click here and we have to press this run button. Okay, after that, if you only want to play like see first 20 records, so we have to type here 20. Okay, so here you can see it is showing us the 20 records for from the data set. For example, if I want to see the last 20 records, so I have to type here the df.tl, and you can simply run it, and it will show you the last 20 records. And you can also see that in this data set we have total 5,571 samples for different kind of for two labels. We have two labels, the ham and spam. Okay, um, okay, so we can move forward. If you want to check the shape of the data set, that how many columns and rows you have, so you can simply go to run this shape command, df.shape, and you can simply run it, and it will show you exactly the number of rows and number of columns. So here we have the 5 columns, and the number of rows in our data set are 5,572. After that, if you want to know about the information, more information, then you can type the df.info, because it's a function there, and you can simply have the more broader aspect from the data set. You can simply df.info and click run. Okay, after now you have loaded the data set. After that, the first and the most important step you have to follow is you have to clean the data set for different kind of noise. So data pre-processing is a very important, because if you're not processing the data, pre-processing the data, then you will not get good results. Okay, so here, as you can see that we have a lot of null values for the two columns unnamed 1, 2, and 4. So we should remove these columns, because these columns don't have any kind of data, so we have to remove them. So here we are using a drop function, df.drop, and we are typing the column names, which is unnamed 1 and unnamed 2, 3, and 4, and in place is equal to true, and access should be 1. Okay, so here just click on this one and type run, and like you can see, we can check the data set again, and we can check the first 10 records. And yeah, as you can see here, you can have the 5 columns, but after the drop function, after applying the drop, you will also, you can see the two columns. Okay, this one is the v1 has the labels and this one has the text. So here you go. After that, as these v1 and v2 are not confused, are very confusing for us, so that's why we need to remove them. So and we have to rename them for our A's. So, okay, so we are like, these are the we are naming v1 with the target and v2 with the text. Okay, so here you go. And after the renaming, you can see that whether it is renamed or not. So this is the target and this one is the other one is the text. So target has the, let me show you the, so here you can see that there's a target column and this is a text column. Target column has our labels and this has our text. So machine learning model will get this label, with get this text, and it will be trained, and after that it will give us the results. Okay, after that we have to apply the label encoder, because we have to convert it into labels, because the computer only works in binary values, so we have to convert ham and spam into labels. So for example, if we want to convert into a label, so we can assign a label ham to 0 and spam to 1. Okay, so here you can simply run this code and it will give you the results. Okay, after that like it has converted the labels into 1 and 0. For example, if you're doing multi-class classification and if you have three classes, so you will be having 0, 1 and 2 labels for your text. Okay, after that, then you have, this is also a very important step, you're checking that whether there are any null values in your columns, in your rows or not. So you have to check them. So you can, how you can check them, df dot is null is basically a function by the help of which you can check them, and dot sum, that it will give you a total sum of null values. So we don't have any null values in our data set, so it is showing us a 0. Okay, after that, we have to check whether the values are duplicated. So we also have to check them, that whether we are, so we actually, it helps us to get the better results, because if you have a sample and if you have a duplicated number of samples, then you will not get good results, because your data is biased data. So that's why you have to check the duplicated value as well. After that, you have to duplicate, you have to drop the duplicates for the removal of biasness. And you can see that first we have 5,572 samples, and after that we will only have 5,169 samples, and it has removed around 600 samples. Okay, so after that, then when the data is pre-processed, you have to go to the exploratory data analysis. You have to explore the data, you have to check the features, you have to explore the number of features. So here you can simply, we are having the number of samples for the 0 label and number of samples for 1 label. Okay, so here you can simply run this code and you will have for label 0 we have 4,516, and for label 1 we have 653 samples. After that, if you want to make a graph, you can run this like plot, so that you can exactly have a visual idea that how much is the percentage for this. So you have to click on here, and it shows us that total the spam messages in our data set are the 12.63% and 87.3% are non-spam messages. Okay, after that you have to, as you can see that the data is not balanced data. It's for 0 we have a lot of samples for label 0, and we have a very less number of samples for 1, so that's why we have to work on it. So after that, you have to import the NLTK, the natural language toolkit library. You can simply type import space NLTK and you can import it. And if you have to download this PUNK, and so that you can tokenize your data. Okay. After that, you have to fetch the number of characters in each text. So yeah, this is df space df brackets num character is you're making a column, and in which you have to apply the length, and it will actually give you the total number of characters in each row. Okay, and after that we can also have a look on the like how actually it looks. So df dot head, and we can type 8 characters here, 8 here, and like you can see that for label 0 we have this is our data, this is a number of characters in this row. So number of characters is are 111. Okay, for the second number of sample we have 29, and here, and it continues to this. Okay, now after that you have to apply, you want to fetch the number of words in each label or in each row for column text. Okay, so how you're gonna do this, you're gonna make a new column which num underscore words. You want to apply this into this text column, df text, and you want to apply NLTK, and you want to apply the tokenization. Okay, so here you go, you will see, you'll be having another column with this name. Okay, so I'm gonna show you the how it actually working. So here you can see that this column contains the number of characters, and this one has the total number of words inside it. Okay, and how you're doing it, you're doing it using a pre-trained model from NLTK, um, and it is showing you the number of words. After that, you are having the total number of sentences in a specific text. So here you go. Like in the same way, you have to make a new column, and you are applying this into the text column in your data, and you're applying sentence tokenizer. Okay, and here you go. It will show you the results for number of characters, number of words, and number of sentences. So here in this sample, we have 2 sentences. Here we have 2. Here we have 1, and so on. Okay. For now, you have to describe the ham or the non-spam messages. So here we can have a describe function, and here you can see the df num character, num words, num sentence dot describe. So it will show you the count, mean, standard, mean, 25 percentile, 50 percentile, and other ones, so that you can have a more broader way. After that, you can have um, for label 0, you want to do that this more broader way. Here you can see the for spam messages, you can see this like for ham and spam. Okay, after that you want to do the plot that to a histogram, so that you can have a more broader idea that this is actually shows us the, this color shows us the 0, and this color shows us the 1. Okay, in the same way, you can also do the same for the target 1 or target 2, so that you can have a more better exploratory analysis that like how is your data set, what are the features, and how are the samples working, and in detail. Okay, after that you have to plot a heat map, so that you can have, basically heat map is to find the by the heat map we can have a correlation between the different features. So here you can see that this is the code, SNS is the library, and df dot corr, this actually shows us the correlations. Okay, so now the your exploratory data is done. Now you have to process the data so that you can design a classification model. So first the step is to convert into a lowercase, then you have to do the tokenization, then you have to remove a special characters, you have to remove a stopped words and punctuations, and then you can have to do a stemming. Okay, so here you can simply stem from NLTK. You have to import the different libraries like stop word, string, and other ones, so that you can do the you can have all these steps, because if you're not doing these steps, you will not get the good results. Okay, so we have basically defined a function in which we are doing all these steps. We are doing the tokenizations as well. So here, for example, like we have to remove the stop words. It is spamming, spammed, spam detection. So in this text, what it will do is it will convert it into a lowercase. It will remove the stop words, and it will remove the punctuations as well. Okay, so here you can see that text transform. We are giving the sample text, and it is showing us this results. Okay. Okay, so here you have to download nltk.download stop words. NLTK words should be English if you're working on a text classification in English language. So you have to type it here English, okay? Okay, so after that, when you will run this, and and you'll spam, it will remove the stop words and punctuations and other things, other irrelevant data. And for example, df text 0, and we have applied um, we want to check that whether we have the results after the pre-processing or not. So transformed, we are making a column which is transformed text, and after that it will df text and apply the text transform, this simple function, and it will pre-process our data for us. Okay, and after that, for example, if you want to have the 20 records, first 20, like you can see, this was our original text, and this is our transformed text, because it have to remove it has to convert it into a lowercase. It has to remove the punctuations, and it has to remove the numbers and special characters as well. So this is our original text, and this is our transformed text after applying the pre-processing technique. After that, we want to do the word cloud. So as the word cloud, when you will see this kind of errors, so simply you have to copy it, and you have to go to the anaconda, and you have to type here pip install anaconda. Pip install word cloud, and it will install the word cloud for you. Okay, and after that you can run it again, and it should work for you. And what actually the word cloud is, word cloud basically shows you that what are the most repeated words for that specific label. Okay, so here we want to make the word cloud for spam. So here you go, you can see that these are the most common words that were most repeated in this whole label. Okay, after that, we want to make the word cloud for ham. We can also do that in the same way, and we can plot it. And here you can see that these are the most repeated. The word that are in like in increase or in bold. So these are the words that are basically the most repeated words in our specific this class or this data. Okay, for ham. Okay, after that we have to do the like we are trying to find out the top most spam messages that were considered as the spam. So we can simply do that. Okay. Okay, so after having the word cloud, now we are going to explore the 30 spam messages. And then you can have to click here, you have to click the length of spam, and then you have to find the DF info. Okay, after that, you have to we are actually checking the frequency of the words, the most repeated words, okay, for spam. So most common spam messages have these words, and it has this frequency. For example, call free to uh, txt text. These are the most common spam messages. These are the most common words in spam messages. Okay, so here by this way you can simply run this and you can have most common words for spam. After that, we are exploring the non-spam messages, that what are the most common words for non-spam. So here you can see the most common uh, non-spam or ham messages are here. Okay, after that, then we have to do the count vectorizer. We have to use the TF-IDF vectorizer so that we can do the we can have the text vectorization using bag of words. Okay, and what is bag of words? Actually, we convert the textual data into the simple array data, and then we have to process it because the computer only knows the binary language, so we have to process the data from text into binary. So this function basically extract the features and it convert the text data into the array data. Okay, here we have the X transformed array, and we are converting it into the using TF-IDF transform. Here's the shape for X. After that, we have the we have the Y variable, okay, which has the number of like the variables, like the number of targets. So we have two labels, 0 and 1, because we have two classes. So that's why I have the um, only the labels for that specific column. Okay. After that, we are using a train test split function, and this function we have to split it into a four different parts, which are X train, X test, Y train, Y test. X train actually has the training data, X test has the testing data, Y train has the labels, and on which X train and Y train, or X train has the text and Y train has the labels. X test has the test data and Y test has the labels. So we are actually splitting it, and how much we are splitting? We are doing the 80-20 split, which means that 0.20 here means that you're splitting the data for 80% for training and 20% for testing. If you want to increase this, you can simply type 0.3, and then there will be 70% data for testing, 70% for training, and 30% for testing. After that, we have to import the from sklearn, we have to import the different naive Bayes, multi-naive Bayes, and we are actually importing the different classifiers. Okay, here in this part. After that, we have to apply the we are actually importing the accuracy metrics and performance evaluation metrics here so that we can evaluate the performance here. After that, first of all, you have to import, for example, if you take the naive Bayes algorithm, okay? So naive Bayes algorithm has this, it says this variable, then you have to put the dot, and you have to fit it for X train and Y train. X train has the textual data, which is converted into the array form, and Y train has the labels. After that, Y predict has the labels that was the predicted on X test. So X test is the data that was totally unseen for the model. Okay, and then we have the accuracy here. So accuracy here is right now the accuracy is 0.87, which means that this naive Bayes algorithm has the accuracy of about 87% accuracy. Okay, and how much what does it mean? The precision, recall, F1 score, and sport. Basically these has the it has the proper definitions: true positive, true negative, and you have to divide it, and then you can calculate this value. Okay, so for label 0, we have the precision is 0.97, which is 97% precision. For 1, we have 0.51, recall is 0.88 and 0.80, and so on. After that, we have to test it for the another classifier, which is multinomial naive Bayes. And so first of all, you have to import it from sklearn. Then you have to make a variable here. And then you have to fit the function, and you have to do the prediction from this specific variable for, and then you have to check the accuracy. So here the accuracy is about 97%. 0.97 means 97% accuracy. After that, we have imported the Bernoulli Bayes algorithm so that we can test it and we can compare the performance. Okay, and in the same way as we have done before, we have to import it from sklearn. After that, we have to make a variable for it. Then we have to fit the function, and after that, we have to use the dot predict on X test data. Okay, and then we have to compute the accuracy. So here the accuracy is 98%. After that, we are checking the other algorithms as well, like logistic regression, support vector machine, decision tree, um, k nearest classifier, neighbors, random forest, AdaBoost, bagging, boosting, and other ones. Okay, so here we are going to check them, then how much accuracy we have, and you can see that no module name XGBoost. Okay, so how to resolve this? You have to just copy it and open an Anaconda prompt, and then here type pip install XGBoost. Okay, so it will install the XGBoost, and then you have to rerun the code in that section, and it will run for you. Okay, it will show you the results. Okay, so you can see that now it's getting installed in our system, and after that you have to click here and you have to rerun it. Okay, so now you can see there are no errors. Okay, so now after that we are actually making the objects for SVC. We have the support vector machine, the kernel is sigmoid, KNC, DDC, decision tree, and other ones. And after that, we are making a CLS for them. Then we have a train classifier, and we have the train class. We are doing the training. So here you can see the results. Like you can see that it is train classifier on SVC, X train, Y train, and Y test. So here you can see that simply it will show you the results for that specific classifier, that what are the actual results. So for SVC, here are the accuracy and precision. For the k nearest neighbor, here's a 90%, precision is 1.0, which means 100%. So by this way, you can simply get the performance. Okay, after that you can make a data frame, and you can have the algorithm name and then accuracy and then precision, so that you can later export this data frame into a CSV or Excel file. Okay, for your submission or for your assignment submission, or to check the results. Okay, so here right now it is performing. So when you will see the star here, it means that the code is actually running in your system. And if you see the number, like we have run this part, so if you see the number here, it means that it has successfully run, and it has successfully computed the code for you. Okay, so thank you so much for watching my video, and we'll see you in the next video. Take care. Bye.